Hello, I'm Karupasamy. I'm going to be doing my third Unix lab experiment. The experiment is about looping control statements in shell programming. The first program is to write a shell script to print the Fibonacci series. So here we have printed using the echo statement, um, um, saying enter the number, and the user will enter the number, and I've got the input using read command. I'm storing 0 to a variable named A and 1 to a variable named B, and I'm printing 0 and 1, and then I'm using a for loop that runs from 0 to n minus 1, and I'm using the increment operator I plus plus. And then for loop we have to give do and done as a brackets in the shell programming, and such a syntax used here. And so what I'm doing here for Fibonacci series is C is equal to A plus B, and we're gonna add these two numbers and store it in C, and we're printing it in C, and then we are interchanging the numbers. The B's value will go to A, and the C's value will go to B, as you can see, and that's the program. So as you can see here, 8 Fibonacci series number are being displayed. So it starts with 0, 1, and it goes on. So 1 plus 2 will give 3, 2 plus 3 will give 5, 5 plus 8 will give 13. So the next program is write a shell script to find the sum of for following series. So what the series does is it adds all the odd numbers, and I mean it's the square of the odd numbers in the limit of n. So the program is over here. So first I've passed the user to enter a number, and I'm taking the number and storing it in n, and I'm initializing a variable c 0, and I'm running my loop from I is equal to 0, and it goes on to the number n, and I'm incrementing it as the loop goes on. And for odd numbers, we have to check if it's it is divided by 2. So if the numbers is not divided by 2, then we are adding it in C. So the value of C is C. So C plus the square of the odd number. So I is the odd number over here. So we are multiplying it twice for the square, and we are adding it in C. And again, the value of C will be added with another pair of numbers. And after the loop gets over, I'm printing the value of C. So that will be a sum. So I'm entering the number 7. So as you can see, 84 is the value of all the sum of square of all the odd numbers. The next program is write a shell script to check the given number is Armstrong number or not. So Armstrong number is um, uh, what it does is it will get all the digits of number, and it will power the numbers in terms of the length of the number. So for example, if 153 is an Armstrong number, what happens is the value of 1 cube plus 5 cube plus 3 cube will be added together, and it will check if the value is equal to 153, and it will actually be equal to 153. So it will print 123 is an Armstrong number. So what the program does is, it first I'm asking the user to enter a number, and for example, I'm entering 150. The length of the 153 will actually as I was saying, if 153 is the input, the length of the 153, that is 3 will be stored in length. I'm using the asterisk symbol for storing the length of the value of number, and we're storing it in the variable length, and 0 in the sum, and the variable old number will carry the original number, that is 153. And I'm giving a condition while the numbers not equal to 0. So until the numbers equal not equal to 0, the loop will go on. When at the time when the number will be equal to 0, it will exit the loop. So for, like as I was saying, the 153, so 153 mod less 10 will become 3. So we're taking 3 first and storing it in remainder, and we're reducing 153 into 15, and we're storing it in the same number. And here what we're doing here is we're taking the power of remainder. So 153, the 3 was a remainder, and so 3 power 3 will be 27, and it will be stored in. So what happened here is, as I was saying, 3, so 3 power 3 will be 27, and it will be stored in the variable power, and sum value is 0, so sum plus 27 will be 27, and then now the value is 15, and it will go check the loop, the condition is true, and then it will come, 5 will be stored in remainder, and 1 will, the number will become 1. The number will become 1, and then the 5 cube will be stored in power again, and now the sum will have 27, so 27 plus 5 cube will get added and again stored in sum, and then the 1 cube will be added, and what happens is 1 by 10 will become 0, and then this condition will be false. So we'll exit the loop, and then we're checking if sum is equal to the variable old number, which has 153. So if both the values are equal, the 153 is an Armstrong number will be printed. So I'm entering 153, and as you see, 153 is an Armstrong number. The next one is write a shell script to check the given number is a palindrome or not. Um, a palindrome number is a number which when reversed will give the same original number. So first, the program for it is over here. First, I'm asking the user to enter a number, and the user will enter a number, and then I'm using a variable named sd, and I'm storing 0, and then RGB, and I'm giving an empty string, which will be helpful for storing the reverse of the number, and then O1 is the original number, which will store the value of n. So for example, I took 101. This while loop will go on until the value of n is less than 0. So the condition is the value of n should be greater than 0. So it goes inside, and as we saw in the previous program, n mod less 10, for example 101 mod less 10 will return 1, and n will become 10 as we divide it by 10, and then the reverse, here what's happening is we just taking the value of reverse and then the SD. The SD's value will be 1, and reverse's value is actually empty right now, so 1 will get printed and stored in reverse, and then at the second 10, 1, and then 0 will be there in the SD, so 10 will get stored, and then the third 10, 101 will get stored in the reverse. And finally, when the value of n becomes 0, it will exit the loop, and then we'll compare reverse and then the original number, and if both are equal, the number is palindrome, otherwise it's not a palindrome. As you can see, 101 is a palindrome number. The next program is write a shell script to print the prime number between the given ranges. So what we're doing here is, first we're getting the range of the um, numbers. So we're asking the user to enter the first number and the second number, and we're running a loop from the first number to the last number, and inside that, to calculate to find if a number is a prime number or not, we have to check if there is the numbers, if whether the number is divisible by the numbers between 2 and that number. So if the number is not divisible, the number is a prime number. If it's divisible, it's not a prime number. So we're running the loop from 2 to that the number, and then we're using J++ for increment, and we're using expression I modulus j. So it will just check if I is divisible by j, and if it's divisible, it will return 0. So if the statement is true, we are assigning p as 1, and once the loop is broken, it will come out and check if p's value is 0. So if like as I said here, if the number is divisible by any number, the p's value will be 1. So we're checking if the value of p is 1. So I mean the value of p is 0, and if the value of p is 0, it is a prime number. So we're printing it now. I'm giving 10, and the next number is 50. So as you can see here, here are all the prime numbers between 10 and 50. The next one is write a shell script to sort elements of an array in both ascending and descending order. Um, so first, we're asking the user to enter the number of elements in the array, and we're reading it in the variable n, and then we're running a loop from 0 to that number n, and we're reading all the numbers that the user enters, and we're storing it in the array, and then we're printing the array just like the user entered the values, and then here we're sorting the array. So for sorting, we're using two different loops. The first loop will run from 0 to n, and the second loop will run from I to n. This is because as a single loop gets executed, the heaviest number will get placed in the first the left side of the array. So we're just skipping the first part to reduce the number of iterations. So what we're doing here is we're checking if the number at ith place is less than the number at j, and if it's so, we're just storing we're swapping the values between the I and the j position in the array. So as the loop goes on, it will get sorted in the descending order. So here we're printing the elements in the descending order, and then here we're printing the elements in the here is in the descending order, and here is ascending order. For ascending order, I've just reversed the same array from n minus 1 to 0. So that's it. So I'm entering 3. So I'll enter 1, 5, and 7. So as you can see here, just like I entered, the array the values in the array are printed here, and then here it's in the descending order, and here it's in the ascending order. That's it. Thank you.